Question 1. Operational review demonstrates that a large enterprise fiber channel and environment is experiencing intermittent connectivity issues and occasional data corruption, alerts on specific storage arrays. The current zoning configuration is a mix of port-based and WWPN-based zoning, with some areas of the fabric having very broad access permissions. The IT team is considering several approaches to stabilize the environment and improve data integrity. Which approach best aligns with Cisco MDS best practices for secure and stable SAN operations? Option A. Remove all zoning configurations to simplify management and allow all devices to discover each other freely. Option B. Consolidate all storage ports into a single zone with all host WWPN and use port-based zoning for individual host isolation. Option C. Implement a host-centric zoning strategy where each zone contains specific host WWPN and the WWPN of the storage ports they are authorized to access, ensuring granular control. Option D. Create large zones that encompass entire racks of servers and storage arrays, relying on the operating system's file system permissions for data security. The correct answer is B. Consolidate all storage ports into a single zone with all host WWPN and use port-based zoning for individual host isolation. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments, ensuring data integrity and availability while managing the complexities of fiber channel zoning. Misconfigurations in zoning can lead to data corruption, service disruptions, and security breaches, impacting business operations and potentially violating service-level agreements, SLAs. The professional challenge lies in understanding the intricate interplay between host initiators, storage targets, and the Cisco MDS fabric, and applying best practices to prevent unintended access or isolation. Correct approach analysis. The correct approach involves implementing a granular, host-based zoning strategy. This means creating zones that explicitly define which host bus adapters, HBA, can communicate with specific storage ports. This method adheres to the principle of least privilege, ensuring that only authorized hosts can access designated storage resources. From a regulatory and best practice perspective, this minimizes the attack surface, prevents accidental data modification by unauthorized hosts, and simplifies troubleshooting by isolating potential issues to specific host storage pairings. This aligns with general IT security principles and data protection guidelines that emphasize access control and data integrity. Incorrect approaches analysis. One incorrect approach is to implement broad, fabric-wide zoning where all hosts can see all storage. This is a significant security and operational risk. It violates the principle of least privilege, making it easy for a compromised host to access sensitive data on other systems or disrupt storage operations. Ethically and professionally, this demonstrates a lack of diligence in protecting data and maintaining system stability. Another incorrect approach is to rely solely on WWPN zoning without considering the host's role or the data it is intended to access. WWPN zoning is a fundamental building block. A purely WWPN-based approach, without a clear strategy for grouping hosts and storage, can become unmanageable and prone to errors as the environment grows. It lacks the strategic intent of ensuring data segregation and can lead to situations where a host has access to storage it shouldn't, even if the WWPN are technically correct. This can indirectly lead to data integrity issues and potential compliance violations if data segregation requirements are not met. A third incorrect approach is to disable zoning altogether. This is the most egregious failure, effectively creating a flat SAN where every device can see every other device. This is a direct contravention of basic security principles and would almost certainly violate any data protection regulations or compliance frameworks that mandate access control and data segregation. It exposes the entire storage infrastructure to unauthorized access and data corruption, leading to severe operational and reputational damage. Professional reasoning. Professionals should approach SAN zoning with a clear understanding of the data flow and access requirements for each application and server. The decision-making process should involve 1. Understanding application data sensitivity and access needs. 2. Mapping host HBAs and storage ports. 3. Designing zones based on host groups and storage groups, adhering to the principle of least privilege. 4. Implementing and rigorously testing zoning configurations. 5. Regularly reviewing and auditing zoning policies to ensure continued compliance and security. This systematic approach ensures that the SAN is not only functional, but also secure and compliant with relevant standards. Question 2. To address the challenge of a critical application server suddenly losing connectivity to its assigned storage array LUNs, while other servers in the same rack and connected to the same switches can still access their storage, what is the most effective and secure initial troubleshooting step on the Cisco MDS 9000 series switches? Option A. Examine the zone configuration on the Cisco MDS switches to verify that the server's HBA WWPN and the storage array's target port WWPN are correctly included in the same zone. Option B. Temporarily disable zoning on all relevant vSAN to see if connectivity is restored. Option C. Update the HBA driver on the affected server to the latest available version. Option D. Create a new zone that includes all server and storage WWPN in the fabric and assign it to all relevant vSAN. The correct answer is A. Examine the zone configuration on the Cisco MDS switches to verify that the server's HBA WWPN and the storage array's target port WWPN are correctly included in the same zone. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments, ensuring data availability and performance for critical applications while managing the complexities of fiber channel zoning. Misconfiguration of zoning can lead to application outages, data corruption, or security breaches, all of which have significant operational and potentially regulatory implications. The professional challenge lies in accurately identifying the root cause of connectivity issues and implementing a solution that is both effective and compliant with established best practices for SAN security and data integrity. The need for precise configuration and validation is paramount. Correct approach analysis. The correct approach involves a systematic and granular investigation of the zoning configuration. By examining the zone configuration on the Cisco MDS switches, specifically looking for the presence of both the server's HBA WWPN and the storage array's target port WWPN within the same zone, a network administrator can directly identify and rectify zoning errors. This method is best professional practice because it directly addresses the most common cause of fiber channel connectivity issues related to access control and isolation. It aligns with the principle of least privilege, ensuring that only authorized devices can communicate, which is a fundamental security tenet in SAN management. This granular approach minimizes the risk of unintended consequences and ensures that the solution is targeted and effective, thereby maintaining data availability and integrity as per operational requirements. Incorrect approaches analysis. Implementing a full fabric zone that includes all devices is a significant regulatory and ethical failure. This approach completely negates the purpose of zoning, which is to segment the SAN and control device access. It creates a security vulnerability by allowing any device in the fabric to potentially access any other device, violating the principle of least privilege and increasing the risk of unauthorized data access or modification. This is professionally unacceptable as it introduces widespread security risks and makes troubleshooting future issues exponentially more difficult. Disabling zoning entirely is another critical failure. Zoning is a fundamental security and operational control mechanism in a fiber channel SAN. Disabling it removes all access control, exposing all devices to all other devices in the fabric. This is a severe security breach and a direct violation of best practices for SAN management, potentially leading to data corruption, unauthorized access, and compliance violations if data privacy regulations are in place. It is professionally irresponsible and creates an unacceptable level of risk. Modifying the server's HBA driver without verifying the zoning configuration is a misguided approach. While HBA driver issues can sometimes manifest as connectivity problems, they are typically not the primary cause of complete connectivity loss to specific storage targets when other servers in the same zone are functioning correctly. This approach wastes valuable troubleshooting time and resources by addressing a less likely cause. More importantly, it fails to address the fundamental access control mechanisms of the SAN, potentially masking the real issue and leaving the SAN in a vulnerable or misconfigured state. This is professionally inefficient and risks overlooking critical configuration errors. Professional reasoning. professionals should approach SAN connectivity issues with a structured troubleshooting methodology. This begins with understanding the symptoms and the expected behavior. The next step is to form a hypothesis about the potential cause, prioritizing the most common and impactful issues. In fiber channel SAN, zoning is a frequent culprit for connectivity problems. Therefore, the professional decision-making process should involve verifying the zoning configuration first, as it directly controls device communication paths. If zoning is confirmed to be correct, then other potential causes, such as HBA driver issues, cable problems, or switch port errors, can be investigated systematically. This layered approach ensures that the most probable causes are addressed first, minimizing downtime and risk. Question 3. The assessment process reveals that a critical storage array containing sensitive customer data is accessible by multiple servers within a large enterprise SAN fabric. The current configuration lacks granular control, allowing any server in the same vSAN to potentially access the storage array. The IT security team has raised concerns about unauthorized data access and potential compliance violations. What is the most effective and secure method to restrict access to this specific storage array to only authorized servers within the fabric, adhering to Cisco MDS 9000 series best practices? Option A. Create a single, broad zone within the vSAN that includes all servers and the target storage array to simplify management. Option B. Implement a comprehensive zoning strategy that defines specific zones for authorized server storage, array communication within the relevant vSAN. Option C. Manually configure access control lists, ACL, on each individual switch port connected to the storage array to filter traffic based on server worldwide names, WWN. Option D. Disable all zoning on the MDS switches and rely solely on host-based access control lists configured on each server. The correct answer is B. Implement a comprehensive zoning strategy that defines specific zones for authorized server storage, array communication within the relevant vSAN. Explanation. Scenario analysis. The scenario presents a common challenge in enterprise SAN environments, ensuring consistent and secure access control across a distributed infrastructure. The professional challenge lies in balancing the need for granular control over sensitive data with the operational overhead of managing numerous access control lists, ACL, and zoning configurations. Misconfigurations can lead to data breaches, service disruptions, or compliance violations. The requirement to adhere strictly to Cisco MDS 9000 series configurations and best practices, as defined by the DCSAN exam syllabus, adds a layer of technical specificity to the problem. Correct approach analysis. Implementing a robust zoning strategy that leverages the Cisco MDS 9000 series capabilities for granular access control is the best professional practice. This involves creating well-defined zones that group specific initiators, servers, with specific target storage arrays, and then applying these zones to the relevant vSAN. This approach directly addresses the need for security by limiting communication paths and preventing unauthorized access to storage resources. It aligns with the principles of least privilege and defense in depth, which are fundamental to secure network design and are implicitly supported by the configuration options available on Cisco MDS switches. The DCSAN syllabus emphasizes these configuration aspects, making this the most appropriate solution. Incorrect approaches analysis. Disabling zoning entirely and relying solely on host-based access controls is a significant regulatory and ethical failure. Zoning on the MDS provides a hardware-level enforcement mechanism that is more robust and less prone to host OS vulnerabilities or misconfigurations. Relying solely on host-based controls bypasses a critical layer of security mandated by best practices for SAN environments and could violate data protection regulations that require strict access controls. Implementing a single, overly broad zone that includes all initiators and targets within a vSAN is also a failure. This approach negates the purpose of zoning, which is to segment traffic and restrict access. It creates a flat network within the vSAN, increasing the attack surface and making it difficult to isolate issues or enforce granular security policies. This would be considered a gross negligence in terms of security implementation and would likely violate compliance requirements for data segregation. Manually configuring ACLs on every port without leveraging zoning is inefficient and error-prone. While ACLs can restrict traffic, they are typically applied at a higher layer and are not the primary mechanism for SAN access control on MDS switches. Relying on this method for granular storage access control is operationally burdensome and increases the likelihood of misconfiguration, which could lead to unauthorized access or denial of service, thus failing to meet professional standards for efficient and secure SAN management. Professional reasoning. Professionals must adopt a systematic approach to SAN security. This involves understanding the specific security features of the deployed hardware, Cisco MDS 9000 series, and aligning them with organizational security policies and relevant regulatory frameworks. The decision-making process should prioritize solutions that offer layered security, granular control, and operational efficiency. When faced with access control requirements, the professional should first consider the most effective and native mechanisms provided by the infrastructure, such as zoning on MDS switches, before resorting to less efficient or less secure alternatives. Continuous monitoring and auditing of configurations are also crucial to maintain security posture and ensure ongoing compliance. Question 4. Risk assessment procedures indicate a potential for service disruption if a new, high-throughput application storage traffic is not properly isolated and managed on the Cisco MDS 9000 series SAN. The application requires dedicated connectivity to specific storage arrays. The current production environment is stable and must remain unaffected during the deployment of this new application. What is the most appropriate and risk-averse approach to configure the network for this new application? Option A. Create a new vSAN for the new application's servers and storage. Configure the necessary zoning within this new vSAN. Thoroughly test the application's connectivity and performance in this isolated vSAN, and then migrate production traffic to the new vSAN during a planned maintenance window. Option B. Immediately configure the new application servers and storage within the existing production vSAN, ensuring the zoning is correctly set up to restrict access to only the intended storage arrays. Option C. Create a new vSAN for the new application servers and storage, configure the necessary zoning, and immediately migrate all production traffic to this new vSAN to ensure it is the primary path for all storage access. Option D. Create a new vSAN for the new application servers, but connect them to the existing production vSAN for storage access to simplify the configuration. The correct answer is A. Create a new vSAN for the new application servers and storage, configure the necessary zoning within this new vSAN, thoroughly test the application's connectivity and performance in this isolated vSAN, and then migrate production traffic to the new vSAN during a planned maintenance window. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments, ensuring data integrity and availability while managing network performance and security. The professional challenge lies in balancing these competing demands, particularly when a new, high-throughput application is introduced. The risk assessment highlights potential disruptions, emphasizing the need for a proactive and technically sound configuration. The pressure to deploy quickly without compromising existing services adds another layer of complexity. Correct approach analysis. The correct approach involves a methodical, phased implementation that prioritizes non-disruptive testing and validation. This aligns with best practices for network and storage configuration, emphasizing the principle of least privilege and minimizing the blast radius of any potential misconfiguration. By first configuring the new vSAN and zoning for the application servers and storage, and then performing thorough testing in isolation, the administrator ensures that the new configuration does not negatively impact existing production traffic. The subsequent migration of production traffic to the new vSAN, after successful validation, is a standard procedure for minimizing downtime and risk. This approach directly addresses the potential for service disruption identified in the risk assessment and adheres to the principle of controlled change management, which is implicitly expected in regulated environments where uptime and data integrity are paramount. Correct approaches analysis. Implementing the new application's connectivity directly into the existing production vSAN without prior isolation or testing is a significant regulatory and ethical failure. This approach disregards the risk assessment findings and introduces an uncontrolled variable into a critical production environment. It violates the principle of change management, which mandates testing and validation before production deployment. Such an action could lead to widespread service outages, data corruption, or security breaches, all of which carry severe regulatory implications and ethical responsibilities for data protection and service continuity. Configuring the new vSAN and zoning, but immediately migrating all production traffic without intermediate testing is also professionally unacceptable. It creates a separate vSAN. The lack of validation before the full migration means that any undetected issues in the new configuration will directly impact all production services. This bypasses a crucial step in risk mitigation and demonstrates a lack of due diligence in ensuring the stability and security of the storage network. Creating a new vSAN and zoning only for the application servers, but not for the associated storage resources, is fundamentally flawed. This incomplete configuration would prevent the application from accessing the necessary storage, rendering the deployment unsuccessful and potentially causing application errors or failures. It demonstrates a lack of understanding of the end-to-end connectivity requirements for storage-based applications and fails to address the core objective of enabling the new application's functionality. Professional reasoning. Professionals in this field must adopt a systematic approach to network and storage configuration. This involves understanding the application's requirements, assessing potential risks, planning the implementation in phases, and rigorously testing each stage. The decision-making process should prioritize stability, security, and data integrity. When introducing new services or configurations, a test and dev/staging, then migrate to prod methodology is essential. This involves creating isolated environments for testing, validating functionality and performance, and then executing a controlled migration to the production environment, often during scheduled maintenance windows. Adherence to change control policies and thorough documentation are also critical components of professional practice. Question 5. Quality control measures reveal inconsistencies in the fiber channel zoning configuration across multiple Cisco MDS 9000 series switches within the enterprise SAN fabric. These inconsistencies are attributed to different teams independently managing zoning on various switches, leading to potential security vulnerabilities and operational disruptions. The organization requires a standardized and auditable approach to zoning that aligns with its security policies and ensures fabric stability. Which of the following approaches best addresses these quality control findings and ensures compliance with best practices for SAN zoning management? Option A. Instruct each storage administrator to manually configure zoning on their assigned switches based on immediate application needs, documenting changes in a shared spreadsheet. Option B. Implement a zone configuration server, DCS, and establish a formal process for defining, reviewing, and distributing zone sets to all switches in the fabric. Option C. Assign a single senior administrator to be solely responsible for all zoning changes across the entire SAN fabric, relying on their expertise to maintain consistency. Option D. Deploy zoning configurations directly from individual application servers to the relevant switches without central oversight. The correct answer is B. Implement a zone configuration server, DCS, and establish a formal process for defining, reviewing, and distributing zone sets to all switches in the fabric. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments where multiple teams manage different aspects of the SAN infrastructure. The challenge lies in ensuring consistent and compliant configuration of zoning, critical security, and operational control across a complex Cisco MDS environment. Misconfiguration can lead to unauthorized access, performance degradation, or complete service disruption. The professional challenge is to implement a robust and auditable zoning strategy that adheres to established security policies and operational best practices, while also being efficient and manageable. Correct approach analysis. Implementing a zone configuration server, DCS, with a robust zone set management process represents best professional practice. This approach centralizes zone definition and distribution, ensuring that all switches in the fabric consistently apply the same zoning policy. This is crucial for maintaining a predictable and secure SAN environment. From a regulatory and compliance perspective, a centralized and documented zoning strategy provides an auditable trail, demonstrating adherence to security controls and access management policies. This aligns with general IT governance principles that emphasize control, consistency, and accountability in critical infrastructure. Incorrect approaches analysis. Deploying a manual, switch-by-switch zoning configuration without a central management tool is a significant regulatory and ethical failure. It introduces a high risk of human error, leading to inconsistencies across the fabric. This lack of standardization makes auditing difficult and increases the likelihood of security breaches due to misconfigured access controls. It fails to demonstrate due diligence in maintaining a secure and controlled environment. Implementing zoning based solely on application requirements without a formal, documented policy and review process is also professionally unacceptable. While application needs are important, they must be integrated into a broader security framework. This approach bypasses necessary security reviews and can lead to ad hoc configurations that may inadvertently grant excessive privileges or create security vulnerabilities. It lacks the structured governance required for compliance. Relying on a single administrator to manage all zoning changes without peer review or automated validation is a critical failure in internal controls. This creates a single point of failure and a significant risk of unauthorized or erroneous changes going undetected. It violates principles of segregation of duties and accountability, which are fundamental to robust IT security and compliance. Professional reasoning. Professionals should adopt a systematic approach to SAN configuration, prioritizing security, compliance, and operational stability. This involves 1. Establishing clear policies and procedures for all SAN configurations, including zoning. 2. Utilizing centralized management tools to enforce consistency and reduce manual errors. 3. Implementing a change management process that includes review, approval, and validation steps. 4. Maintaining comprehensive documentation and audit trails for all configuration changes. 5. Ensuring segregation of duties where possible. Question 6. Consider a scenario where an application server connected to a Cisco MDS 9000 series SAN fabric is reporting an inability to access its designated storage LUNs. The application is critical for business operations, and downtime is highly undesirable. Initial troubleshooting has ruled out physical connectivity issues and HBA driver problems. The network administrator suspects a zoning misconfiguration within the fabric. What is the most appropriate and secure course of action to restore connectivity for the application server? Option A. Modify the zoning to include only the WWNs of the application server's HBAs in a zone that is already active in the correct vSAN, without verifying the target storage ports. Option B. Disable all zoning configurations across the entire SAN fabric temporarily to allow all devices to communicate freely, and then re-enable them later. Option C. Create a new zone that includes the WWNs of all servers and storage devices in the fabric, and activate this zone in all vSAN to ensure universal connectivity. Option D. Verify that the specific WWNs of the application server's HBAs are correctly included in the zone that grants them access to the target storage ports, and confirm this zone is activated in the correct vSAN. The correct answer is D. Verify that the specific WWNs of the application server's HBAs are correctly included in the zone that grants them access to the target storage ports, and confirm this zone is activated in the correct vSAN. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments, ensuring data availability and performance while managing the complexities of fiber channel zoning. Misconfiguration of zoning can lead to complete loss of access for critical applications, impacting business operations and potentially violating service-level agreements, SLAs. The professional challenge lies in accurately identifying the root cause of the connectivity issue and implementing a solution that restores service without introducing further disruption or security vulnerabilities. The need for precise configuration and understanding of the underlying protocols is paramount. Correct approach analysis. The correct approach involves a systematic and granular examination of the zoning configuration. By verifying that the specific WWNs of the host bus adapters, HBA, on the application server are correctly included in the zone that grants them access to the target storage ports, and that this zone is activated in the correct vSAN, you directly address the most probable cause of the connectivity failure. This method is best professional practice because it is precise, minimizes the scope of potential errors, and directly targets the configuration element responsible for controlling access in a fiber channel fabric. It aligns with the principle of least privilege, ensuring that only authorized devices can communicate, which is a fundamental security and operational best practice in SAN environments. Incorrect approaches analysis. Disabling all zoning on the fabric is a severe security and operational failure. It removes all access controls, potentially exposing sensitive data to unauthorized servers and violating data segregation policies. This approach is akin to leaving all doors unlocked in a secure facility and is professionally unacceptable due to the extreme security risk and the complete disregard for controlled access. Creating a new zone that includes all WWNs from all servers and storage devices in the fabric and activating it is also a critical failure. This is the opposite of proper zoning, creating a broadcast domain for all traffic and eliminating any segmentation. It introduces significant security risks by allowing any device to communicate with any other device, potentially leading to data corruption, unauthorized access, and performance degradation due to excessive traffic. This approach fundamentally misunderstands the purpose of zoning, modifying the zoning to include only the WWNs of the application server's HBAs in a zone that is already active in the correct vSAN, without verifying the target storage ports, is an incomplete solution. While it addresses the host side of the connectivity, it fails to ensure that the storage ports are also correctly zoned to receive traffic from the host. This could still result in connectivity issues if the storage ports are not properly included in a zone that the host can access. It represents a partial fix that might not resolve the problem and indicates a lack of thoroughness in the troubleshooting process. Professional reasoning. When troubleshooting SAN connectivity issues, a professional must adopt a methodical approach. Start with the most likely cause, which in a fiber channel environment is often zoning. Always verify configurations against documented requirements and best practices. When making changes, do so in a controlled manner, ideally during a maintenance window, and always have a rollback plan. Understand the implications of each configuration change on security, availability, and performance. Prioritize solutions that are precise and minimize the blast radius of any potential errors. In this case, the professional decision-making process involves 1. Understanding the symptoms application server cannot access storage. 2. Hypothesizing the cause zoning issue. 3. Testing the hypothesis by examining the relevant zoning configuration. 4. Implementing the most precise fix. And 5. Verifying the resolution. Question 7. The investigation demonstrates that a critical business application hosted on a Cisco MDS 9000 series then is experiencing intermittent performance degradation, leading to user complaints and potential SLA breaches. Initial reports suggest high latency and occasional transaction timeouts. The storage administrator needs to identify the root cause within the SAN fabric. Which of the following diagnostic approaches is the most appropriate and professionally sound method to begin troubleshooting this issue? Option A. Initiate a comprehensive packet capture on the application server's network interface to analyze application-level communication patterns. Option B. Immediately disable flow control on all interfaces within the affected vSAN to reduce potential network overhead. Option C. Escalate the issue directly to Cisco TAC without performing any initial on-switch diagnostics to expedite vendor involvement. Option D. Examine Cisco MDS switch interface statistics, error counters, and traffic flow data for signs of congestion, packet loss, or unusual traffic patterns within the SAN fabric. Correct answer is B. Immediately disable flow control on all interfaces within the affected vSAN to reduce potential network overhead. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments, ensuring data integrity and availability while managing the complexities of a Cisco MDS SAN. The challenge lies in diagnosing and resolving a performance degradation issue that impacts critical business applications. The professional must balance the need for rapid resolution with the imperative to avoid further disruption or data loss, all while adhering to established operational procedures and potential regulatory compliance requirements related to data access and availability. The pressure to restore service quickly can lead to hasty decisions, making a systematic and informed approach crucial. Correct approach analysis. The correct approach involves a methodical investigation that leverages the diagnostic tools and features inherent to Cisco MDS switches, specifically focusing on traffic analysis and performance metrics. This aligns with best practices for SAN management, which emphasize proactive monitoring and reactive troubleshooting using vendor-specific tools. By examining interface statistics, traffic patterns, and error counters, the administrator can pinpoint the source of congestion or packet loss. This systematic method ensures that the root cause is identified rather than just treating symptoms, leading to a more stable and reliable solution. Furthermore, this approach supports any regulatory requirements that mandate auditable logs of troubleshooting steps and system performance, demonstrating due diligence in maintaining data infrastructure. Incorrect approach is analysis. Implementing a broad, untargeted configuration change, such as disabling flow control globally, is professionally unacceptable. This action bypasses the diagnostic process and introduces a high risk of unintended consequences, potentially exacerbating the performance issue or causing data corruption. Such a reactive, broad-stroke approach fails to adhere to change management best practices and could violate regulatory mandates that require controlled and tested modifications to critical infrastructure. Another incorrect approach is to immediately escalate to a vendor support case without performing initial, on-switch diagnostics. While vendor support is valuable, failing to gather basic diagnostic data first demonstrates a lack of fundamental troubleshooting skills and can lead to inefficient use of support resources. This can also delay resolution if the vendor requires this information, potentially impacting service level agreements, SLAs, and any associated compliance obligations for data availability. Finally, focusing solely on the application layer without considering the underlying storage network is a flawed strategy. While application issues can manifest as network performance problems, neglecting the SAN infrastructure means the root cause might be missed entirely. This can lead to prolonged downtime and a failure to meet regulatory requirements for data accessibility and integrity if the SAN is the actual bottleneck. Professional reasoning. Professionals facing such a scenario should follow a structured troubleshooting methodology. This typically involves 1. Understanding the scope and impact of the issue. 2. Gathering initial symptoms and relevant logs. 3. Formulating hypotheses about potential causes. 4. Testing hypotheses systematically, starting with the most likely or easiest to verify. 5. Using appropriate diagnostic tools, in this case, Cisco MDS features like show interface, show logging, show FCNS, show traffic commands, and potentially span/rspan. 6. Implementing changes in a controlled manner with rollback plan. 7. Verifying the resolution and documenting the process. This disciplined approach ensures that solutions are effective, minimize risk, and meet operational and regulatory standards. Question 8. Upon reviewing the current configuration of a Cisco MDS 9000 series SAN fabric, it has been observed that all servers and storage arrays are configured within a single vSAN. This setup lacks any specific zoning, meaning any device can potentially discover and communicate with any other device on the fabric. The primary objective is to enhance data security and prevent unauthorized access to sensitive storage resources, while also ensuring that different application environments do not interfere with each other's storage access. What is the most effective approach to achieve these goals? Option A. Create a single, large vSAN that encompasses all devices and implement extensive access control lists, ACL, on the fabric interfaces to filter traffic. Option B. Implement vSAN to logically segment the fabric based on application environments or security zones, and then configure zone sets within each vSAN to permit communication only between specific initiators and targets. Option C. Remove all existing configurations and rely solely on host operating system-level access controls to manage storage access. Option D. Configure port-based zoning on all interfaces to restrict communication between individual devices without creating separate vSAN. The correct answer is B. Implement vSAN to logically segment the fabric based on application environments or security zones, and then configure zone sets within each vSAN to permit communication only between specific initiators and targets. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments, ensuring consistent and secure access to data across multiple servers and applications. The complexity arises from the need to balance performance, availability, and security requirements within the constraints of a Cisco MDS 9000 series SAN. Misconfigurations can lead to data corruption, service outages, or unauthorized access, all of which have significant operational and potential compliance implications. The professional challenge lies in understanding the intricate interplay of zoning, vSAN, and security features to achieve the desired outcome, without introducing unintended consequences. Correct approach analysis. Implementing a robust zoning strategy that leverages vSAN for isolation and granular access control represents best professional practice. This approach directly addresses the need for security and availability by segmenting the SAN. vSAN provide logical separation, preventing traffic from one vSAN from interfering with another, thereby enhancing stability and security. Within each vSAN, zoning further refines access by defining which devices, initiators, and targets can communicate. This ensures that only authorized devices can discover and access specific storage resources. This aligns with general IT best practices for network segmentation and access control, which are implicitly supported by the security objectives of any regulatory framework governing data handling, even if not explicitly detailed in the exam's specific jurisdiction. The principle is to enforce the principle of least privilege at the fabric level. Incorrect approach is analysis. Using a single vSAN for all devices and relying solely on host-based access controls is professionally unacceptable. This approach fails to provide the necessary fabric-level isolation. If a misconfiguration or security breach occurs on one host, it could potentially impact all other devices within the same vSAN, leading to widespread data corruption or denial of service. This lack of segmentation increases the attack surface and makes troubleshooting significantly more difficult. From a regulatory perspective, this approach would likely be considered a failure to implement adequate security controls for data segregation and protection. Implementing port-based zoning without vSAN, while offering some level of device-to-device control, is less effective for comprehensive isolation. It can become cumbersome to manage in large environments and does not provide the same level of logical separation as vSAN. If the physical port configuration changes or a switch is replaced, the zoning configuration might need extensive rework. This approach is less resilient and more prone to errors, increasing the risk of unintended access or communication failures, which could have regulatory implications if data integrity or availability is compromised. Ignoring zoning altogether and relying solely on application-level security is a critical professional and regulatory failure. The SAN fabric is a foundational layer for storage access. Without proper fabric-level controls, the security of the entire storage infrastructure is compromised. Application-level security can be bypassed if unauthorized access is granted at the SAN level. This would be a direct violation of principles requiring robust data protection mechanisms, as it leaves data vulnerable at a fundamental level. Professional reasoning. Professionals should approach SAN configuration by first understanding the logical and physical requirements of the environment. This involves identifying distinct security domains and availability requirements. The decision-making process should prioritize a layered security approach, starting with fabric segmentation using vSAN, followed by granular access control through zoning. Thorough documentation of the zoning and vSAN configuration is crucial for auditing and troubleshooting. Regular review and testing of the configuration are essential to ensure ongoing compliance and security posture. When faced with a choice between a simpler but less secure configuration and a more complex but robust one, the latter should always be chosen when dealing with sensitive data or critical infrastructure. Question 9. The assessment process reveals that a financial services organization is experiencing intermittent connectivity issues between its application servers and critical financial data storage arrays managed by Cisco MDS 9000 series switches. To expedite troubleshooting, a network engineer proposes temporarily disabling Fiber Channel Security Protocol (FCSP) authentication on the relevant vSAN to see if it resolves the connectivity problem, with the intention of re-enabling it later. The organization operates under U.S. financial regulations that mandate strong authentication and access controls for sensitive financial data. Which of the following actions represents the most compliant and professionally sound approach to address the connectivity issue while adhering to regulatory requirements? Option A. Temporarily disable FCSP authentication on the affected vSAN to isolate the connectivity issue, documenting the change and planning for immediate re-enabling and verification once the root cause is identified. Option B. Advise the application server administrators to bypass the SAN fabric and connect directly to the storage arrays using alternative network interfaces if available to circumvent potential SAN-related issues. Option C. Implement granular zoning changes to restrict access to only the necessary storage ports for the affected application servers, while keeping FCSB authentication enabled. Option D. Proceed with disabling FCSB authentication on the affected vSAN and postpone re-enabling it until a full security audit can be performed, as this will allow for more thorough investigation of the connectivity problem. The correct answer is A. Temporarily disable FCSB authentication on the affected vSAN to isolate the connectivity issue, documenting the change and planning for immediate re-enabling and verification once the root cause is identified. Explanation. The assessment process reveals a common challenge in enterprise storage environments, ensuring data integrity and availability while adhering to stringent regulatory compliance mandates. In the context of Cisco MDS 9000 series switches, DCSAN, this often involves configuring features like Fiber Channel Security Protocol, FCSB, and zoning to control access and prevent unauthorized data modification or exposure. The professional challenge lies in balancing robust security configurations with the operational need for efficient data access and troubleshooting. Misconfigurations can lead to compliance violations, data breaches, or service disruption, all of which carry significant financial and reputational risks. The correct approach involves a systematic and documented process for implementing and verifying security configurations. This includes understanding the specific regulatory requirements applicable to the organization's industry and jurisdiction, translating those requirements into concrete technical controls on the MDS switches, and establishing a robust change management process with thorough testing and validation. For instance, implementing FCSB with strong authentication mechanisms and granular zoning policies directly addresses the regulatory need to protect sensitive data from unauthorized access and modification. This proactive and compliant approach minimizes the risk of audit failures and security incidents, representing best professional practice by prioritizing data security and regulatory adherence. Incorrect approaches often stem from a lack of understanding of the underlying regulatory requirements or a rushed implementation without proper validation. For example, disabling FCSB to simplify troubleshooting or improve performance without a documented risk assessment and compensating controls constitutes a regulatory failure. This bypasses a critical security mechanism designed to prevent unauthorized access and authentication spoofing, directly violating principles of data protection and integrity mandated by various compliance frameworks. Similarly, implementing overly broad zoning that allows unnecessary access between hosts and storage devices, even if unintentional, can lead to data exposure and unauthorized modification, failing to meet the least privilege principle often embedded in regulatory guidelines. Another failure would be to implement security features without proper documentation or a rollback plan, making it impossible to demonstrate compliance during an audit or to quickly recover from unintended consequences. A professional decision-making process for such situations should involve a thorough understanding of the organization's compliance obligations, a detailed assessment of the technical controls available on the Cisco MDS platform, and a risk-based approach to implementation. This includes consulting with compliance officers, performing thorough testing in a lab environment, and adhering to strict change control procedures. When faced with operational challenges, professionals must always evaluate the security and compliance implications of any proposed workaround or configuration change, ensuring that any deviation is temporary, documented, and has appropriate mitigating controls in place. Question 10. Examination of the data shows that a recent internal audit identified potential gaps in the visibility of data access within the Fiber Channel SAN. The organization is subject to regulations requiring detailed logging of all access to sensitive data and strict controls over who can initiate such access. The Cisco MDS 9000 series switches are the central fabric for this SAN, which configuration approach best ensures compliance with these regulatory mandates. Option A. Configure zone sets to restrict access to specific storage resources and enable detailed logging of all fiber channel traffic on the MDS switches, focusing on login/logout events and data access commands. Option B. Rely solely on host-based operating system logs for tracking data access, assuming that all relevant information will be captured at the server level. Option C. Implement broad, unrestricted access to all storage resources and only enable logging for critical system errors, assuming that most data access is legitimate. Option D. Disable detailed logging on the MDS switches to improve performance, as regulatory requirements are often interpreted loosely in practice. The correct answer is A. Configure zone set to restrict access to specific storage resources and enable detailed logging of all fiber channel traffic on the MDS switches, focusing on login/logout events and data access commands. Explanation. This scenario presents a professional challenge in ensuring regulatory compliance within a Cisco MDS 9000 series SAN environment, specifically concerning data access and audit logging. The core difficulty lies in balancing operational efficiency and security requirements with the stringent mandates of data privacy and integrity regulations. Professionals must navigate the complexities of configuring the MDS switches to meet these obligations without compromising network performance or introducing vulnerabilities. The correct approach represents best professional practice because it directly addresses the regulatory requirement for comprehensive audit trails and controlled data access by implementing specific access control lists, ACL, and enabling detailed logging on the MDS switches. Administrators create a verifiable record of who accessed what data and when. This aligns with regulations that mandate accountability and the ability to audit data access for security and compliance purposes. The configuration ensures that only authorized personnel can access sensitive data, and all actions are logged for retrospective analysis, which is a cornerstone of many data protection frameworks. An incorrect approach that fails to implement granular access controls and comprehensive logging would be professionally unacceptable. This failure constitutes a direct violation of regulatory requirements that mandate data protection and auditability. Specifically, it could lead to unauthorized data access, data breaches, and an inability to demonstrate compliance during an audit. The ethical failure lies in neglecting the responsibility to safeguard sensitive information and maintain the integrity of the system. Another incorrect approach, such as relying solely on host-based logging without leveraging the network infrastructure's capabilities, is also professionally deficient. While host-based logs are important, they may not capture all network-level access events or provide the centralized, switch-level visibility required by many regulations. This oversight can create gaps in the audit trail, making it impossible to provide a complete picture of data access. The professional decision-making process for similar situations should involve a thorough understanding of applicable regulations, a detailed assessment of the SAN environment architecture, and a proactive approach to configuration. Professionals must prioritize security and compliance by default, using the MDS switches features to enforce policies and generate necessary audit data. This involves consulting regulatory documentation, understanding the specific logging and access control capabilities of the Cisco MDS platform, and testing configurations to ensure they meet both operational and compliance objectives. Question 11. Performance analysis shows that a financial services organization is experiencing an increase in audit findings related to unauthorized access to sensitive data stored on its Cisco MDS 9000 series SAN infrastructure. To address these findings and ensure compliance with data protection regulations, which configuration approach on the MDS 9000 series switches is most critical for establishing a secure and auditable environment? Option A. Implement granular, role-based access control RBAC to restrict administrative privileges to only necessary functions and users, and enable comprehensive logging of all administrative activities and configuration changes. Option B. Disable all logging features on the switch to minimize the storage footprint and reduce potential performance overhead. Option C. Configure the switch to deny all administrative access by default, requiring manual intervention for any management task. Option D. Rely solely on physical security measures to protect the SAN infrastructure, assuming logical access controls are less critical. The correct answer is A. Implement granular role-based access control RBAC to restrict administrative privileges to only necessary functions and users, and enable comprehensive logging of all administrative activities and configuration changes. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments where regulatory compliance is paramount. The professional is tasked with configuring a Cisco MDS 9000 series switch to meet specific data retention and auditing requirements. The challenge lies in balancing the technical implementation of security features with the strict mandates of data protection regulations. Misinterpreting or misapplying these regulations can lead to significant legal repercussions, financial penalties, and reputational damage. The need for precise configuration and thorough documentation is critical to demonstrate adherence to the law. Correct approach analysis. The correct approach involves leveraging the Cisco MDS 9000 series built-in security features, specifically role-based access control (RBAC) and audit logging, to enforce compliance with data protection regulations. RBAC ensures that only authorized personnel can access or modify sensitive data, directly addressing the principle of least privilege often mandated by regulatory frameworks. Comprehensive audit logging provides an immutable record of all administrative actions, crucial for demonstrating accountability and facilitating investigations in case of a breach or noncompliance. Configuring these features according to best practices and regulatory guidelines ensures that the storage infrastructure is not only secure, but also legally defensible. This approach aligns with the principles of data integrity and confidentiality, which are cornerstones of most data protection laws. Incorrect approaches analysis. Implementing a blanket denial of all administrative access to the switch, while seemingly secure, fails to meet operational requirements and is not a compliant solution. Regulations typically require authorized access for management and maintenance. This approach would render the switch unmanageable and therefore non-compliant with operational necessities. Disabling all logging features on the switch, even with the intention of reducing storage overhead, is a severe regulatory failure. Most data protection laws mandate comprehensive logging and auditing capabilities to track access and changes to sensitive data. Disabling logging directly undermines the ability to prove compliance and investigate incidents, leading to potential penalties. Relying solely on physical security measures without implementing robust logical access controls and audit trails is insufficient. While physical security is important, it does not address the risks associated with unauthorized remote access or insider threats, which are key concerns for regulatory bodies. This approach leaves the data vulnerable to logical attacks and unauthorized manipulation. Professional reasoning. Professionals must adopt a proactive and compliance-driven approach to network device configuration. This involves thoroughly understanding the applicable regulatory framework, in this case, implied U.S. regulations for data protection and auditing in enterprise environments, and mapping its requirements to the capabilities of the Cisco MDS 9000 series. The decision-making process should prioritize features that directly address compliance mandates, such as RBAC for access control and comprehensive logging for auditability. Documentation of the configuration, including the rationale behind specific settings and their alignment with regulatory requirements, is essential for demonstrating due diligence. Regular reviews and updates of configuration to reflect evolving regulations and security best practices are also critical. Question 12. Quality control measures reveal that during a recent network performance issue investigation on Cisco MDS 9000 series switches, a network engineer bypassed standard access controls and exported unencrypted diagnostic logs containing customer account identifiers to a shared network drive for analysis. Which of the following configurations and procedures best aligns with regulatory compliance for handling sensitive data in a financial services environment? Option A. Performing troubleshooting without logging administrative actions and exporting sensitive data in plain text to local workstations for individual analysis. Option B. Disabling security features on the switches to allow unrestricted access for faster troubleshooting and exporting raw logs to a publicly accessible cloud storage for broad team access. Option C. Using a single administrative account with full privileges for all troubleshooting tasks and sharing diagnostic output via unencrypted email to expedite problem resolution. Option D. Implementing role-based access control (RBAC) to restrict access to sensitive commands and data, enabling comprehensive logging of all administrative actions, and encrypting any exported diagnostic data before transfer. The correct answer is D. Implementing role-based access control (RBAC) to restrict access to sensitive commands and data, enabling comprehensive logging of all administrative actions, and encrypting any exported diagnostic data before transfer. Explanation. Scenario analysis. This scenario presents a professional challenge related to data security and regulatory compliance within a financial services environment, specifically concerning the configuration of Cisco MDS 9000 series switches. The core difficulty lies in balancing the need for efficient network operations and troubleshooting with the stringent requirements of data privacy and integrity mandated by financial regulations. The potential for unauthorized access or data leakage during diagnostic procedures, especially when involving sensitive customer information, necessitates a highly controlled and auditable approach. The challenge is amplified by the inherent complexity of SAN environments and the need for skilled personnel to navigate these configurations without compromising security. Correct approach analysis. The correct approach involves utilizing the Cisco MDS 9000 series switches' built-in security features and logging mechanisms to perform diagnostic tasks in a manner that is both effective and compliant. This includes employing role-based access control (RBAC) to limit access to sensitive commands and data, enabling comprehensive logging of all administrative actions, and encrypting any exported diagnostic data. This aligns with the principles of data protection and auditability expected in regulated industries. By adhering to these practices, the organization ensures that troubleshooting activities do not inadvertently expose sensitive information, and that a clear audit trail exists to demonstrate compliance with regulatory requirements for data handling and security. This proactive stance minimizes the risk of breaches and regulatory penalties. Incorrect approaches analysis. One incorrect approach involves disabling security features or using broad administrative privileges to expedite troubleshooting. This directly violates regulatory mandates that require robust security control to protect sensitive data. Such actions create significant vulnerabilities, increasing the risk of unauthorized access, data exfiltration, and potential breaches, which can lead to severe financial penalties and reputational damage. Another incorrect approach is to export raw, unencrypted diagnostic logs containing potentially sensitive information to an insecure location or to personnel without proper authorization. This is a direct contravention of data privacy regulations that mandate the protection of sensitive data in transit and at rest. The lack of encryption and access controls makes the data susceptible to interception and misuse, leading to compliance failures and potential data breach incidents. A third incorrect approach is to perform diagnostic tasks without documenting the actions taken or the data accessed. Regulatory frameworks, particularly in financial services, require a detailed audit trail of all system access and configuration changes. The absence of such documentation hinders the ability to demonstrate compliance during audits and makes it impossible to investigate security incidents effectively. This lack of accountability is a significant regulatory and ethical failure. Professional reasoning. Professionals in this domain must adopt a risk-based approach to network management and troubleshooting. This involves understanding the specific regulatory requirements applicable to their industry and jurisdiction, and then configuring network devices like Cisco MDS 9000 series switches to meet those requirements. The decision-making process should prioritize security and compliance, even if it introduces minor complexities in operational tasks. This means leveraging built-in security features, implementing granular access control, ensuring comprehensive logging, and encrypting sensitive data. When faced with a troubleshooting scenario, the professional should always consider the potential impact on data security and regulatory compliance before executing any action. If a task cannot be performed in a compliant manner, alternative, secure methods must be sought or the task must be deferred until appropriate security measures can be implemented. Continuous training and awareness of evolving regulatory landscapes are also crucial for maintaining best practices. Question 13. Analysis of the configuration of fiber channel zoning on Cisco MDS 9000 series switches within a regulated financial institution. What is the most compliant and secure approach to segmenting access between production database servers and development servers to prevent unauthorized data exposure and meet data segregation mandates? Option A. Create zones based on switch port numbers rather than device identities to allow for flexible device placement. Option B. Configure a default zone that allows all devices on the fabric to communicate with each other, assuming that host-based firewalls will provide sufficient security. Option C. Create separate, specific zones for production database servers and development servers, ensuring that only the necessary initiators and targets within each respective domain are members of their designated zone. Option D. Implement a single, broad zone that includes all production database servers and all development servers to simplify management. The correct answer is C. Create separate, specific zones for production database servers and development servers, ensuring that only the necessary initiators and targets within each respective domain are members of their designated zone. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise storage environments where security and compliance are paramount. The challenge lies in balancing the need for efficient data access and management with strict regulatory requirements for data segregation and access control. Misinterpreting or misapplying zoning configurations can lead to unauthorized access, data breaches, or compliance violations, which can have severe financial and reputational consequences. The complexity of fiber channel zoning, especially in large MDS deployments, demands meticulous planning and adherence to established best practices and regulatory mandates. Correct approach analysis. The correct approach involves implementing a robust and compliant zoning strategy that aligns with the principles of least privilege and data isolation. This means creating specific zones for different security domains, such as production servers, development environments, and management interfaces. Each zone should contain only the necessary devices, initiators, and targets required for their specific function. This granular control ensures that traffic is restricted to authorized communication paths, preventing unauthorized access between different data sets or environments. This directly supports regulatory frameworks that mandate data segregation and access control to protect sensitive information. For example, if the regulatory framework requires separation of financial data from development data, this zoning approach enforces that separation at the network fabric level. Incorrect approaches analysis. One incorrect approach is to implement a wide open or default zoning policy where all devices can communicate with each other. This is a significant regulatory and security failure because it completely bypasses the principle of least privilege and data isolation. It creates a flat network where any compromised device could potentially access any other device or data on the fabric, leading to severe data breaches and non-compliance with regulations requiring data protection and segregation. Another incorrect approach is to create overly broad zones that encompass multiple, unrelated security domains. For instance, grouping production servers with development servers in the same zone violates the principle of data isolation. This increases the attack surface and the risk of accidental or malicious data exposure. It fails to meet regulatory requirements for separating sensitive data from less sensitive environments. A third incorrect approach is to neglect regular auditing and review of zoning configurations. Zoning policies can become outdated as the environment evolves, leading to security gaps or misconfigurations. Failing to audit zoning regularly means that outdated or incorrect configurations might persist, posing a risk of non-compliance and security vulnerabilities. Regulatory frameworks often mandate regular security assessments and audits to ensure ongoing compliance. Professional reasoning. Professionals should approach zoning configuration with a security-first mindset, always considering the regulatory implications. The decision-making process should involve 1. Understanding the data classification and sensitivity levels within the organization. 2. Identifying distinct security domains and their communication requirements. 3. Designing zones based on the principle of least privilege, ensuring each zone contains only necessary devices. 4. Documenting zoning policies thoroughly and obtaining necessary approvals. 5. Implementing zoning configurations meticulously on the Cisco MDS switches. 6. Establishing a rigorous process for regular auditing, testing, and updating of zoning configurations to maintain compliance and security posture. Question 14. Stakeholder feedback indicates an urgent need to provision new storage for a critical application deployment. The storage infrastructure is managed by Cisco MDS 9000 series switches. To expedite the deployment, a proposal is made to leverage existing zoning configurations and security policies, assuming they are adequate for the new application's data access requirements, and proceed with provisioning immediately. What is the most appropriate course of action to ensure regulatory compliance? Option A. Deploy the storage with the assumption that existing security and zoning policies are adequate and address any potential compliance gaps post-deployment if they arise. Option B. Conduct a thorough review of the proposed storage configuration, including zoning, access control lists, and auditing capabilities, against the specific requirements of the applicable regulatory framework before provisioning. Option C. Proceed with provisioning the storage using the existing configurations without any specific review, as the urgency of the application deployment takes precedence over detailed compliance checks. Option D. Provision the storage immediately using existing configurations and document the setup afterward, assuming current policies are sufficient. The correct answer is B. Conduct a thorough review of the proposed storage configuration, including zoning, access control lists, and auditing capabilities, against the specific requirements of the applicable regulatory framework before provisioning. Explanation. This scenario presents a professional challenge due to the inherent tension between operational efficiency and the stringent requirements of regulatory compliance in data storage and access. Specifically, the need to quickly provision storage for a new application must be balanced against the mandate to ensure all data handling adheres to the established security and auditing policies, which are often dictated by regulatory frameworks. The complexity arises from the potential for rapid deployment to bypass or inadvertently violate these controls if not carefully managed. The correct approach represents best professional practice because it prioritizes a thorough review and validation of the proposed storage configuration against the established regulatory framework before deployment. This ensures that the new application's data access patterns, security controls, and auditing mechanisms are compliant from the outset. This proactive stance minimizes the risk of post-deployment remediation, data breaches, or regulatory penalties. It aligns with the principle of security by design and demonstrates a commitment to responsible data governance, which is a cornerstone of regulatory compliance in data management. An incorrect approach that involves deploying the storage without a formal compliance review fails to uphold the regulatory framework. This bypasses critical security and auditing checks, creating a significant risk of non-compliance. Such an action could lead to unauthorized data access, data integrity issues, or a lack of auditable trails, all of which are direct violations of data protection and privacy regulations. Ethically, it represents a disregard for the organization's responsibility to protect sensitive data and adhere to legal obligations. Another incorrect approach, which is to assume existing configurations are sufficient without verification, is also professionally unacceptable. Complacency in regulatory matters is dangerous. Configurations can become outdated, or new application requirements might expose vulnerabilities in existing controls. Relying on assumptions rather than explicit validation can lead to subtle but critical compliance gaps that may only be discovered during an audit, resulting in significant repercussions. This approach demonstrates a lack of due diligence and a failure to adapt to evolving security and regulatory landscapes. Finally, an approach that involves documenting the configuration after deployment, but without prior validation, is insufficient. While documentation is important for auditing, it does not prevent non-compliance during the operational phase. The regulatory framework mandates that controls are in place, an effective asterisk before asterisk data is processed or stored. Post-deployment documentation without pre-deployment verification is a reactive measure that does not satisfy the proactive requirements of most regulatory mandates. The professional decision-making process in such situations should involve a clear understanding of the applicable regulatory framework, a risk-based assessment of the proposed deployment, and a structured process for validating compliance before any operational changes are made. This includes engaging relevant compliance and security teams early in the project lifecycle and establishing clear go/no-go criteria based on regulatory adherence. Question 15. The evaluation methodology shows that after a critical security incident impacting data availability on the Cisco MDS 9000 series switches, the immediate priority is to restore service. However, a thorough risk assessment must be conducted before any configuration changes are implemented to prevent recurrence and ensure ongoing compliance. Which of the following actions best aligns with this risk-informed approach to incident remediation? Option A. Conduct a comprehensive vulnerability scan and penetration test on the affected DCSAN infrastructure to identify all potential attack vectors and weaknesses, followed by a phased remediation plan based on the identified risks. Option B. Implement a temporary workaround that bypasses the affected security controls to restore service quickly, with plans to address the underlying security issue in a future maintenance window. Option C. Focus solely on restoring data access by reconfiguring the affected ports and zoning, and then document the incident for post-mortem analysis at a later date. Option D. Immediately revert the switch configuration to the last known stable state before the incident occurred, assuming this will resolve the issue and prevent future attacks. The correct answer is A. Conduct a comprehensive vulnerability scan and penetration test on the affected DCSAN infrastructure to identify all potential attack vectors and weaknesses, followed by a phased remediation plan based on the identified risks. Explanation. This scenario presents a professional challenge because it requires balancing the immediate need for network functionality with the long-term implications of security vulnerabilities. The Cisco MDS 9000 series switches are critical components of a storage area network, SAN, and any misconfiguration or oversight in their security posture can lead to significant data breaches, service disruptions, and compliance failures. The pressure to restore service quickly can lead to shortcuts that bypass essential risk assessment steps, making careful judgment paramount. The correct approach represents best professional practice because it prioritizes a thorough risk assessment before implementing changes. This aligns with the principle of security by design and proactive risk management, which are fundamental to maintaining a secure and compliant IT infrastructure. Specifically, in the context of U.S. regulations governing data protection and network security, e.g., NIST frameworks, HIPAA for healthcare data, PCI DSS for payment card data, though not explicitly stated as the jurisdiction. These are common frameworks for SAN security considerations in a U.S. context. A systematic risk assessment is a mandated or strongly recommended practice. It ensures that potential threats are identified, vulnerabilities are understood, and mitigation strategies are put in place before they can be exploited. This proactive stance minimizes the likelihood of future incidents and demonstrates due diligence in protecting sensitive data. An incorrect approach that involves immediately reverting to a previous configuration without assessing the root cause of the issue is professionally unacceptable. This fails to address the underlying vulnerability that led to the incident, leaving the system susceptible to similar attacks in the future. It also bypasses the opportunity to learn from the incident and improve security controls. From a regulatory perspective, this could be seen as a failure to implement adequate security measures, potentially violating requirements for ongoing risk management and vulnerability remediation. Another incorrect approach, which is to only address the immediate symptom and deploy a quick fix without a comprehensive security review, is also professionally unsound. While it might restore functionality, it ignores potential broader security implications. This can lead to a false sense of security and leave other, undiscovered vulnerabilities unaddressed. Regulatory frameworks often require a holistic approach to security, not just reactive patching. Finally, an approach that focuses solely on performance tuning and ignores the security implications of the configuration changes is a significant ethical and regulatory failure. Security and performance are not mutually exclusive. They must be considered in tandem. Neglecting security in favor of performance can create exploitable pathways, leading to data breaches and noncompliance with data protection laws. This demonstrates a lack of understanding of the interconnectedness of network operations and security responsibilities. The professional decision-making process for similar situations should involve a structured incident response plan that includes a mandatory risk assessment phase. This phase should involve identifying the scope of the incident, analyzing the root cause, evaluating potential impacts, including data confidentiality, integrity, and availability, and determining appropriate remediation steps that consider both immediate needs and long-term security posture. Professionals should always consult relevant security policies, industry best practices, and applicable regulatory requirements to guide their decisions. Question 16. Research into the configuration of Cisco MDS 9000 series switches for financial services data center has revealed a need to implement new zoning policies. Given the sensitive nature of financial data and the stringent regulatory environment in the U.S., which of the following approaches to assessing the risks associated with these zoning changes best aligns with professional best practices and regulatory expectations? Option A. Immediately implement the new zoning policies based on vendor best practices, and then perform a post-implementation review to identify any functional issues, assuming security will be addressed in a later, separate project. Option B. Rely solely on the default zoning configurations provided by Cisco, as these are designed to be secure, and proceed with implementation without further risk analysis. Option C. Conduct a comprehensive risk assessment involving security architects, network engineers, and compliance officers to identify potential impacts on data confidentiality, integrity, and availability, and to define mitigation strategies before implementing the new zoning policies. Option D. Focus exclusively on verifying that the new zoning policies allow for the required data flow and application access, and defer any security-specific risk analysis until after the changes are fully operational. Correct answer is C. Conduct a comprehensive risk assessment involving security architects, network engineers, and compliance officers to identify potential impacts on data confidentiality, integrity, and availability, and to define mitigation strategies before implementing the new zoning policies. Explanation: this scenario presents a professional challenge because it requires balancing the immediate need for network functionality with the long-term security posture of a critical infrastructure component. The Cisco MDS 9000 series switches are integral to data center operations, and any misconfiguration or oversight during a risk assessment can have cascading effects on data availability, integrity, and confidentiality. The pressure to restore service quickly can lead to shortcuts that bypass essential security validation steps, creating vulnerabilities. The correct approach represents best professional practice because it systematically identifies, analyzes, and prioritizes risks associated with the configuration changes. By involving relevant stakeholders and documenting the process, it ensures transparency and accountability. This aligns with general IT governance principles that emphasize a structured and documented approach to change management and risk mitigation. Specifically, within the context of U.S. regulations governing critical infrastructure, such as those overseen by CISA, Cybersecurity and Infrastructure Security Agency, a thorough risk assessment is a foundational element of maintaining operational resilience and security. The process ensures that potential threats are understood and that appropriate controls are implemented before the changes are fully deployed, thereby minimizing the likelihood of security incidents and ensuring compliance with any relevant data protection or operational security mandates. An incorrect approach that prioritizes speed over thoroughness fails to adequately identify potential security weaknesses introduced by the configuration. This could lead to the deployment of a system that is vulnerable to unauthorized access or data breaches, which would be a direct violation of data protection regulations like HIPAA, if healthcare data is involved, or NIST cybersecurity framework guidelines, which mandate risk management. Another incorrect approach that relies solely on vendor defaults without a specific assessment of the operational environment neglects the unique threat landscape and compliance requirements of the organization. This can result in a configuration that is insecure for the specific use case and may not meet regulatory obligations for data security and privacy. A third incorrect approach that focuses only on functional testing without considering security implications overlooks critical aspects of risk assessment. Functionality does not equate to security, and a system that works perfectly but has exploitable vulnerabilities is a significant security and regulatory liability. Professionals should employ a decision-making framework that begins with understanding the scope and impact of the proposed changes. This involves identifying all potential risks, assessing their likelihood and impact, and then developing mitigation strategies. The process should be iterative and involve collaboration with security teams, compliance officers, and operational staff. Documentation at each stage is crucial for auditability and continuous improvement. When faced with time constraints, the framework should guide professionals to prioritize the most critical security checks and to implement temporary compensating controls if necessary, rather than skipping essential risk assessment steps. Question 17. Strategic planning requires a thorough evaluation of new technology deployments to ensure alignment with organizational security posture and compliance mandates. When considering the implementation of Fiber Channel over Ethernet (FCoE) on Cisco MDS 9000 series switches to enhance storage network performance, what is the most critical initial step to ensure a secure and compliant deployment? Option A. Rely solely on the Cisco MDS 9000 series configuration guides for FCOE to ensure correct technical implementation, assuming security is adequately covered by default settings. Option B. Focus exclusively on optimizing the FCOE performance metrics and throughput, as enhanced performance is the primary driver for this technology adoption. Option C. Conduct a comprehensive risk assessment that specifically evaluates the security implications and potential vulnerabilities introduced by enabling FCOE, considering the existing security policies and regulatory requirements. Option D. Proceed with the FCOE configuration immediately, prioritizing the performance gains, and address any security concerns that may arise post-implementation. The correct answer is C. Conduct a comprehensive risk assessment that specifically evaluates the security implications and potential vulnerabilities introduced by enabling FCOE, considering the existing security policies and regulatory requirements. Explanation. Scenario analysis. This scenario presents a common challenge in enterprise IT environments where the implementation of new technologies, such as advanced fiber channel over Ethernet, FCOE capabilities on Cisco MDS switches, must be balanced against existing security policies and the need for robust risk assessment. The challenge lies in ensuring that the proposed configuration, while offering potential performance benefits, does not introduce unacceptable security vulnerabilities or compliance gaps. The pressure to adopt new features quickly can sometimes overshadow the critical due diligence required for a thorough risk assessment, making it difficult to prioritize security and compliance over perceived immediate gains. Correct approach analysis. The correct approach involves a comprehensive risk assessment that explicitly considers the security implications of enabling FCOE on the MDS 9000 series switches. This aligns with best practices in network security and data center management, which mandate a proactive approach to identifying, analyzing, and mitigating potential threats. Specifically, this would involve evaluating the security posture of the FCOE implementation, including authentication, encryption, if applicable and supported, access controls, and potential attack vectors. The assessment should also consider the impact of any new vulnerabilities that might arise from the integration of FCOE with existing infrastructure. This methodical approach ensures that any deployment is aligned with the organization's security policies and any relevant regulatory frameworks governing data protection and network integrity. Incorrect approaches analysis. Implementing FCOE without a dedicated risk assessment that scrutinizes its security implications is a significant regulatory and ethical failure. It bypasses fundamental security principles that require understanding and mitigating risks before deploying new technologies. This approach demonstrates a disregard for due diligence and could lead to breaches of data confidentiality, integrity, or availability, potentially violating regulations that mandate secure data handling. Prioritizing the immediate performance benefits of FCOE over any security considerations is also a failure. This demonstrates a lack of understanding of the interconnectedness of performance and security in a regulated environment. Security is not an optional add-on. It is an integral part of any robust IT infrastructure. Neglecting it can expose the organization to significant legal and financial repercussions if a security incident occurs. Focusing solely on the technical configuration steps for FCOE, as outlined in vendor documentation, without a broader risk assessment, is insufficient. Vendor documentation typically focuses on functionality and basic configuration, not on the specific security context and risk appetite of an individual organization. Relying solely on this can lead to a technically functional but insecure deployment, failing to meet the organization's unique security and compliance obligations. Professional reasoning. Professionals should adopt a risk-based approach to technology adoption. This involves a structured process of identifying potential threats and vulnerabilities, assessing their likelihood and impact, and determining appropriate mitigation strategies. Before implementing any new feature or technology, especially one that impacts network infrastructure and data transport like FCOE, a thorough risk assessment should be conducted. This assessment should involve relevant stakeholders, including security, compliance, and operations teams. The findings of the risk assessment should then inform the decision-making process, ensuring that any deployment aligns with the organization's security policies, compliance requirements, and overall risk tolerance. This proactive and systematic approach is crucial for maintaining a secure and compliant IT environment. Question 18. The control framework reveals a critical vulnerability has been identified in the firmware of the Cisco MDS 9000 series switches, posing a significant risk to the storage area network supporting the organization's core financial transaction processing. Given the sensitive nature of these operations and the potential for service disruption, what is the most prudent approach to address this vulnerability? Option A. Defer patching until a more stable firmware version is released or until the risk of exploitation is deemed imminent, to avoid any potential disruption to financial operations. Option B. Conduct thorough testing of the patch in a lab environment that closely replicates the production SAN, followed by a phased rollout to production switches, starting with less critical infrastructure and progressing to core systems, with continuous monitoring and a defined rollback strategy. Option C. Apply the patch to all production MDS switches as soon as it is available, without extensive testing, to mitigate the risk of exploitation as quickly as possible. Option D. Immediately deploy the patch to all production MDS switches during the next scheduled maintenance window, with a clear rollback plan. The correct answer is D. Immediately deploy the patch to all production MDS switches during the next scheduled maintenance window, with a clear rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge in network security where a newly identified vulnerability requires immediate attention, but the potential impact on critical business operations is significant. The challenge lies in balancing the urgency of patching a known exploit with the risk of introducing instability or downtime to a production environment that supports sensitive financial transactions. The Cisco MDS 9000 series switches are integral to the storage area network, SAN, and any misconfiguration or disruption can have severe consequences for data availability and integrity, directly impacting regulatory compliance and business continuity. The need for a rapid, yet controlled response is paramount. Correct approach analysis. The correct approach involves a phased rollout of the patch, starting with a controlled test environment that mirrors the production SAN as closely as possible. This allows for validation of the patch's effectiveness against the vulnerability and assessment of its impact on performance and stability without risking the live environment. Following successful testing, the patch is deployed to a subset of production switches during a scheduled maintenance window, with rollback procedures clearly defined. This iterative approach minimizes risk by allowing for early detection of issues and provides a mechanism to revert if necessary. This aligns with best practices for change management and risk mitigation, ensuring that security updates are applied responsibly and do not inadvertently compromise the availability of critical services, which is a key consideration under general IT governance and risk management principles applicable to financial institutions. Incorrect approaches analysis. Applying the patch directly to all production switches without prior testing is a significant regulatory and ethical failure. It demonstrates a disregard for risk assessment and change management protocols, potentially leading to widespread service disruption. This could violate service-level agreements, SLAs, and in a regulated financial environment could be seen as a failure to maintain adequate controls over critical IT infrastructure, potentially leading to breaches of data integrity or availability requirements mandated by financial regulators. Implementing the patch only on non-critical switches and ignoring the core infrastructure is also professionally unacceptable. While it might seem like a cautious step, it leaves the most critical components of the SAN vulnerable to the exploit. This selective patching fails to address the overall risk to the organization's most sensitive data and transaction processing capabilities, representing a failure to adequately protect critical assets and potentially violating the principle of comprehensive security coverage. Delaying the patch indefinitely due to fear of disruption is another failure. While risk mitigation is important, complete inaction in the face of a known vulnerability is negligent. It exposes the organization to a high probability of exploitation, which could result in data breaches, financial losses, and severe reputational damage. This inaction directly contradicts the proactive security posture expected of organizations handling sensitive data and could lead to non-compliance with data protection and cybersecurity regulations. Professional reasoning. Professionals should adopt a structured risk-based approach to security patching. This involves 1. Understanding the threat, identifying the vulnerability and its exploitability. 2. Assessing the impact, determining the potential consequences of exploitation on business operations and data. 3. Evaluating the solution, understanding the patch and its potential side effects. 4. Planning the deployment, developing a detailed plan that includes testing, phased rollout and rollback procedures. 5. Executing and monitoring, implementing the plan and continuously monitoring the environment for any adverse effects. This systematic process ensures that security measures are implemented effectively while minimizing disruption to critical services. Question 19. Which approach would be most appropriate for a network administrator tasked with configuring fiber channel over Ethernet, FCoE, on Cisco MDS 9000 series switches to ensure a secure and stable SAN environment? Option A. Focus exclusively on optimizing FCoE performance metrics, assuming that standard SAN security practices are sufficient. Option B. Prioritize the rapid deployment of FCoE to leverage its performance benefits, addressing any issues that arise post-implementation. Option C. Implement FCoE with minimal configuration changes, relying on default settings to expedite the process. Option D. Conduct a comprehensive risk assessment to identify potential security vulnerabilities and operational impacts before and during FCoE implementation. The correct answer is D. Conduct a comprehensive risk assessment to identify potential security vulnerabilities and operational impacts before and during FCoE implementation. Explanation. This scenario presents a professional challenge because implementing new storage technologies, such as fiber channel over Ethernet, FCoE, on Cisco MDS switches, introduces potential security vulnerabilities and operational risks that must be proactively identified and mitigated. The complexity of integrating FCoE with existing SAN infrastructure requires a thorough understanding of both the technology's capabilities and its potential impact on the overall security posture. Careful judgment is required to balance the benefits of modernization with the imperative to maintain data integrity and availability. The correct approach represents best professional practice because it aligns with the fundamental principles of risk management and cybersecurity, which are implicitly or explicitly mandated by regulatory frameworks governing data protection and IT infrastructure security. A comprehensive risk assessment, encompassing technical, operational, and security aspects, ensures that potential threats and vulnerabilities associated with FCoE deployment are identified, analyzed, and prioritized. This systematic process allows for the development of targeted mitigation strategies, such as implementing appropriate security controls, updating access policies, and conducting thorough testing, thereby minimizing the likelihood and impact of adverse events. This proactive stance is crucial for demonstrating due diligence and compliance with industry best practices and any applicable data security regulations. An incorrect approach that focuses solely on performance benefits without a commensurate security evaluation would represent a significant regulatory and ethical failure. It would violate the principle of least privilege and the requirement to protect sensitive data from unauthorized access or disclosure. Ignoring potential vulnerabilities, such as misconfigurations in FCoE encapsulation or inadequate zoning, could lead to data breaches or service disruptions, which are often reportable incidents under various data protection laws. Another incorrect approach that prioritizes rapid deployment over thorough testing would also be professionally unacceptable. This haste could result in the introduction of unaddressed bugs or security flaws in the FCoE implementation, leading to unexpected system behavior, performance degradation, or security exposures. Such an approach demonstrates a lack of professional responsibility and a disregard for the potential consequences of a flawed deployment, which could have severe financial and reputational repercussions for the organization. The professional decision-making process for similar situations should involve a structured risk assessment framework. This framework should include phases for risk identification, e.g., through threat modeling and vulnerability scanning, risk analysis, evaluating the likelihood and impact of identified risks, risk evaluation, prioritizing risks based on their severity, and risk treatment, developing and implementing mitigation strategies. Furthermore, continuous monitoring and review of the implemented controls are essential to adapt to evolving threats and ensure ongoing compliance and security. Question 20. The review process indicates that the organization is planning to integrate fiber channel over Ethernet FCoE into its existing Cisco MDS 9000 series SAN infrastructure, What is the most appropriate risk assessment approach to ensure a secure and compliant integration? Option A. Delegate the entire risk assessment process to the FCOE vendor to leverage their expertise and ensure a quick sign-off. Option B. Expedite the FCOE deployment by prioritizing speed over a detailed risk assessment, relying on the vendor's security claims. Option C. Conduct a comprehensive risk assessment that specifically evaluates the security implications of FCOE within the MDS 9000 environment, considering its convergence with Ethernet and potential impact on existing security controls and compliance requirements. Option D. Assume that existing fiber channel security policies are adequate for FCOE and proceed with the integration, as FCOE is a storage protocol. Correct answer is C. Conduct a comprehensive risk assessment that specifically evaluates the security implications of FCOE within the MDS 9000 environment, considering its convergence with Ethernet and potential impact on existing security controls and compliance requirements. Explanation. Scenario analysis. The scenario presents a common challenge in network security where a new technology, fiber channel over Ethernet, FCOE, is being introduced into a Cisco MDS 9000 series SAN environment. The challenge lies in ensuring that the risk assessment for this integration is comprehensive and aligns with established best practices for data center security and compliance, without introducing new vulnerabilities or violating existing security policies. The complexity arises from the need to understand how FCOE interacts with the existing SAN infrastructure, and how to identify potential risks that might not be apparent with traditional fiber channel. Correct approach analysis. The correct approach involves a thorough risk assessment that specifically addresses the unique characteristics of FCOE within the MDS 9000 environment. This includes evaluating potential vulnerabilities introduced by the convergence of Ethernet and fiber channel, such as increased attack surface, potential for traffic congestion impacting storage performance, and the need for robust authentication and authorization mechanisms for FCOE traffic. It also necessitates understanding how FCOE impacts existing security controls and compliance requirements, ensuring that the integration does not create gaps in data protection or regulatory adherence. This approach represents best professional practice because it is proactive, systematic, and focused on identifying and mitigating risks before they can be exploited, thereby safeguarding data integrity and availability. Incorrect approach is analysis. One incorrect approach would be to assume that existing fiber channel security policies are sufficient for FCOE without specific review. This fails to acknowledge that FCOE operates over Ethernet, introducing different threat vectors and requiring consideration of Layer 2 security mechanisms, VLAN segmentation, and potential denial of service attacks that are more prevalent in Ethernet environments. This approach risks regulatory noncompliance if data protection standards are not met due to unaddressed FCOE-specific risks. Another incorrect approach would be to prioritize the speed of deployment over a detailed risk assessment. This is professionally unacceptable as it bypasses critical security due diligence. The haste to implement new technology can lead to the overlooking of significant security flaws, potentially resulting in data breaches, service disruptions, and severe financial and reputational damage. This directly contravenes the ethical obligation to protect organizational assets and data. A third incorrect approach would be to delegate the risk assessment solely to the FCOE vendor without independent verification. While vendor input is valuable, it should not replace an internal, objective assessment. Relying exclusively on vendor assurances can lead to blind spots, as vendors may not fully understand the specific nuances of the organization's existing infrastructure and risk appetite. This can result in a failure to meet internal security standards and potentially violate compliance mandates that require an independent evaluation of security controls. Professional reasoning. Professionals should adopt a structured risk management framework. This involves identifying assets, threats, vulnerabilities, and potential impacts. For new technologies like FCOE, the process must include a deep dive into the technology's architecture, its integration points with existing systems, and the specific security controls required at each layer. This systematic approach ensures that all potential risks are considered, prioritized, and addressed through appropriate mitigation strategies, aligning with both technical best practices and regulatory obligations.